Um, so, so my talk title, Agency at Boundary, and yeah, it's kind of the theme individual to me is kind of very central, but I was a bit confused what should I talk this time, because I just start my slide. So, I mean, for the people who knows me, I originally from AI, artificial life. So this is my PhD study on like Francisco Barrera autopoietic cell. Um, but that's already, I don't know, 22 years ago. And after that, like last 15 years, I've been working on more like a slightly different kind of perspective on the like self and environment boundary. So more like how we as a human mind to see your body from the environment. So it's more like how to broaden, self-body, self-agency, self-body ownership from the environment. And more recently, I'm going to more like hallucination, Also, reality is not just environment. We kind of confuse between your imagination and percept. So it's all about, yeah, how to make a boundary, and it's actually very fragile, even for human mind. So I feel like I'm supposed to talk about this, but today I actually decided to talk a bit different stuff. And yeah, contents of my today's talk is actually heavily rely on the guy there, like Manuel Bacchieri, and the other one with Kazuya Horibe. So these are the two pieces I just contributed to this special issue on Loyal Society philosophical transaction, and with Takashi Ikegami is also one of the guest editor. And so the current status, the one with the manual is already accepted, but the one on the bottom is not still under the review. So I might be saying completely wrong, but yeah, please excuse me. Don't attack me too much. Okay, so yeah, basically my talk is consists of these two recent papers. And you can see from the title, this is a bit more like mathematical or conceptual or even like just an opinion piece. So I didn't really have my own study. It's just more like an overview of the field of how people actually formally try to define individuality or agency. Okay, so yeah, I feel this slide is more like reiteration, like a lot of people in this symposium talking about, how to define individuality. And yeah, of course, it's a very like a central how to define individuality in what is life, what is agent, and especially with the current AI era, we need to define what is an agent compared to the, separate from the just passive machine. And yeah, like physical system, of course, it's just following the physical law, or we as observer to draw a boundary between the system and non-system. And maybe chemical system is a bit more complicated, like a turbulence, like oil droplet. It just self-organize something, but without any goal. And when it's coming to the biological system, of course, we have more like complete system. Looks like having a goals, and boundary looks like determined by itself. And we have also, that we're kind of a spectrum between, primitive animal, primitive creatures to the human, but it's kind of all same. But then, okay, we have also somewhere in the borderline, like virus, mitochondria, or, stomach, they are like, looks like an individual, but in a sense, it's like a metabolically it's still depending on the other stuff. Or AI robot, of course, or social network. These are not like traditional way to think about agency. But even like this is another my topic, like meditation or psychedelic state, which bit different type of mind. To me, this is also like a human mind. Human, it's not always agency. Human is not always agency. Like when you're in a very sleepy, you're actually losing this kind of individual or this unified sense of self. So I feel like even like a human mind, we need to think about like where's the boundary between like being an agent or being a more distributed mind. Okay, and a key dimension I just put a lot of people thinking about individuality in many different dimensions or properties or things like that. But today, from the title of our paper, I'm going to more like agency. So I think that the reason is that the individuality in like a biological system is kind of still like a very strong assumption of this chemical, biological, like a physical boundary notion or self-sustainment. And that's what I started from. But if you just stay this for long, like you cannot actually get away from just the biological system, because I'm also interested in like AI, human, and other type of systems. So we just get away from the self-sustainment to more like a broader concept called agent. So it's just working with definition. Agent here informally just means the goal-directed system acting in an environment. I think that each word actually makes some strong meaning, like agent should have a goal directed, but also acting in an environment. And from this perspective, so one of the seminal paper already Kepler introduced, but Javier Brandiera, I think he wrote this paper when he was in Sussex still, yeah, and where I actually was before. And he just define agency from 3 different important components. I think that he called the requirement. Like you need like 3 requirements to define agency. And one is, yeah, individuality here now just a component of to define agency. What defines the agent as a distinct entity. Here, it doesn't need to be the physical entity, but something need to be separate from the other system. And second part is normativity. This is maybe slightly, I don't know, I actually took some time to understand why normativity is important. But it's basically normativity is a goal. The system has to have a goal to regulate itself. It's not just doing something as a self-organized way. And the third one is, it's a long name, interactional asymmetry, which basically means action. Like system has some asymmetrical relationship with environment. Environment, of course, affects the system, but a system or agent should have more effect to the environment. That's my take. Okay. And this is my young me and young Xavier in San Sebastian, I think 2011, 12, yeah. Okay, so this is actually still very influential paper. I think that it's already, I don't know, more than 10 years ago, but we kind of still stick to this definition of agency. I don't know. Maybe there's more, alternative way, but we just stick to this requirement or factors to define agency. So from here, with manual, we still stick to these 3 requirements for agency, but we just try to classify or map the existing approach and agency, but only taking a formal one, like a mathematical one. So agency with the 3 requirements, and the point is each approach is not just within one circle. It can be one approach can actually try to answer the question about normativity and individuality same time. But we try to put each approach into the one circle. So I just put all of them. We have 3, so 11 approaches we kind of categorize into these 3 domains. And from next 3 slides, I just try to briefly address all this approach without using any math. So please follow me. And please correct, because some of the study actually done by people here, like Nathaniel and Martin. So please correct me later. Okay, the first one, relational method, which basically said for individual to exist, it must be distinguished from the environment, but also you cannot be completely detached from the world. It should be coupled as well. So there is a kind of how to define a relationship between the system with the environment. And I think the first one is by Randy Baer on dynamical system approach. So he actually did a lot of study after this, using game of life, defined a glider pattern as an agent. So he did a lot of analysis on that. But conceptually, he just said agent is some kind of coupling between some part of the system interacting with other part of the system, and within a kind of viability constraint. So if you go out from this viability constraint, the system dies, sorry, agent dies. So it needs to be some kind of, self-preserving property as well. Free energy principle, I think that this one is more popular for like a theory about like brain and cognition, like by Carl Friston. But actually, Friston claimed this principle is actually applied to define living system. And to me, it's more like agency actually. So the system can actually act on the world, updating their belief. But the important thing is, he claimed, once you have this Markov blanket, this is just a statistical boundary of the system. Once you can draw this boundary, the system inside this boundary can be seen as inferring the external world, modeling the world. So that's how he tried to bridge a gap between like a property as living and a property of like cognitive, entity to like I'll say, see the world more, know the world basically. But yeah, it's kind of, the Markov blanket is about like this relational approach to define the boundary, but of course his idea is also combined with predictive coding. So also system has the ability to, have some norm to achieve the goal. But yeah, but still this is like a relational approach because he just started from nothing, just a particle, and you can just define some kind of system and environment from, still this is observer's viewpoint. I will go back to this. Bayesian interpretation map by Nathaniel and Martin. This is more like taking Dennett intentional stance. So it's just acknowledge system has its own belief, and if the belief is in corresponding to the interpreter's, observer's belief. Sorry, maybe I'm wrong. You can define the kind of belief in the system, and also you can define like when the observer's interpretation of the belief is matching with the system's belief. But yeah, it's more like to me dualistic. Like you actually define the system has a belief, but it can be it's different from what observer actually see. And Cartesian frame, I'm not really into this, but it's more like a category theoretic work on the agency. And it's kind of similar to the, other things. So you just define like a whole system, just use this kind of the frame from agent action and the environment pair to the consequences. So there's also you can actually define the agency boundary from this kind of matrix. Yeah, I didn't actually go through this paper, but they use a kind of category theory method to conclude some kind of a property with kind of system. So maybe I just talked too much for already. Okay, so the prediction-based method is I put here that to achieve the goal, there is a kind of assumption the agent must predict the future of itself or environment. So they kind of, change the kind of idea. So having a norm, having a goal means agent can predict the system in the future. And I think one of this approach is information theory individuality. And I think this is a quite straightforward. They use information theoretic method, just define the agent past and agent future, agent present and agent future, and how much the current state of the agent can have information on the next state of the agent compared to the environmental effect to the agent. Agent and device, this is more like, this is actually taking the Dennett intentional stance. You define the agent as kind of how much you can see the system as an agent compared to seeing the system as more like a mechanical, physical stance. And see they actually do the model comparison, Bayesian model comparison, which model can explain or can predict the whole behavior more. So it's very like taking observer's perspective very seriously. Other stuff, complete local integration by Martin Bell. This is another kind of idea, like agent can be defined as a spatial temporal pattern that every part makes every other part more probable. So if the system as a whole is more appears to be probable compared to the just sum of the other part, the agent, you can define that as an agent. Anticipatory system by Rosen. This is more, again, like a category theoretic stuff, but to me, conceptually, it just, he'd say like the system, if they have a model, it's an agent. I just say it very briefly. I don't really get the mathematics background in this one. Okay, and the causality-based method, I think this is slightly less important for individuality because this is related with action. And in this genre, there's the assumption is we take the agent as a, if the internal state of the agent is the actual genuine cause of the action, then that is an agent. So there's one called actual causation. It's taking the IIT integrated information seriously. So that if the information is integrated in the internal state, you can see there is a system to act. And another one is mechanical causal graph. This is more like a system using like a policy and also like a do operation with a PAL information theoretic, causal inference method to define the action. The last one is the semantic information by Artemy Koretinsky and David Wolpert. This is another way to define a causality by scrambling the sensory input and until the system, like if the scrambling the input and the system die, it's not a good scrambling. But if you can like keep the scrambling, keeping the system survive, if the information going through this, scrambling, this is a semantic information for surviving. So that's the way he defined the agency as a like actual causal effect of the action. Okay, I think I almost running out of time. 10 minutes. I don't get like it's not. Oh, I still have 27 minutes in total, like including the discussion. Okay. So, sorry, I just very quickly go through all of them. I feel like I made some long statement, but please correct me. Like we have all the expertise. So, as I said, like if we put these different kind of approach into this map, like free energy principle is kind of relational, but also prediction based. Information theory of individuality. It's actually, as title said, like it's actually definition of the individuality, but it's actually very prediction based. So it's somewhere in between. And yeah, these are all kind of this side causality things is somewhere here. And as I said, I just try to make a map. So yeah, in our paper we just describe all this method into just three domain. But actually, these top three are more like dynamical system approach. See the system as a just, there's no variable, there's no system and environment just starting from just a pure dynamical system. Whereas these central part is all using information theory, but, a bit different way. And these, I think, bottom right one is very close to this integrated information idea by Giulio Tononi. And then like a left and right part, I think these are all very based on intentional stance, which means we observer take the view. Interpretation from the observer is actual, is a part of the definition of agency. Some part of these are very category theoretic. And the last one, I think the free energy Bayesian interpretation map and anticipatory system heavily rely on this internal model principle, which is basically coming from Roche Ashby's work on a good regulator theorem. Like a system should have a model, should be a model of the world if the system control in a good way. So I think these are kind of another assumption, like when some system there, if there's an internal state having a model, that is maybe a candidate of the agent. Okay, so this is just a kind of, again, classification of these different approaches, mainly actually by some of guys in the audience. And these are actually, observer dependent or not. That's a kind of question. Okay, as I said, some approach take explicitly this, intentional stance, means observer is actually the involved. It's not the observer independent. You cannot actually exclude the observer to define agency. But actually, even the original paper by the Xavier Brown Dillon, these three components, three requirements should be intrinsic. He of course didn't explain, like he doesn't actually explain what intrinsic here means, but at least he claimed these properties should be intrinsic, not the property we actually attribute. But those approaches, some of them actually, yeah, sorry, I already said that, but yeah, some of them is actually observer dependent, but some even didn't say explicitly it's intrinsic. It's still, if you use the information theoretic approach, still some part is observer dependent. You need to still define what is an important variable, what is the environment, like still, you cannot just leave it and it's automatically define the system itself. So in our study, we actually take explicitly as if stance, like all these methods only talk about as if agency. We don't actually, so it means these methods cannot actually distinguish the actual agent from just the agent, looks like agent, like just a simulated agent. But I think that's kind of our, these approaches limitation. We cannot, because these are all kind of measurement, like we just take some variable from the system and define the agency from this. So of course we cannot go beyond the actual mechanism inside. But if we take this kind of as if stance, actually we have some implication from this. So that's the next slide I try to talk. So for example, oh yeah, sorry, before going to that, I'll just explain a bit more about like all this method actually still use this kind of as if stance. For example, this boundary, the relational method in the boundary one, like a Markov blanket, like people like Frisson said, this is like a membrane, like system has its own membrane to sustain by itself. But Markov blanket as a definition, you can actually define anywhere, you cannot, the free energy principle doesn't actually explain like how to generate Markov blanket from inside. It's just a definition. And like Nathaniel's work, Bayesian interpretation map is actually taking observer's point of view from the beginning. So it's not, he didn't claim it's intrinsic. Prediction-based method, they also use, so for example, this agent and device one, it's actually claim it's just intentional stance. Like you see agent as you see system as agent or mechanical stuff. You actually attribute that and just check, which model can explain more. So this is the observer's point of view. And this causality-based method, this is also have a problem if you take the intrinsic way, because most of the work actually use this parse do operation. And do operation normally, the scientist as observer actually execute. If the system is, there's something inside the system do the do operation, it's a bit contradicting because we cannot, it means like the system inside can actually affect the physical law, which shouldn't be happen. So it's a bit difficult the position you take if you think this do operation as an intrinsic variable. So as if stance actually can avoid these problematic assumptions. So this is maybe like just a safer stance to take this. Okay, and more so on top of that, if we take this as if view, it's actually the normativity and identity is kind of very similar concept. For example, when we see this relational approach on individuality, they often see the agency as defined as a distinct entity from the environment. But to do that, the system itself needs to have some kind of the self-preserving mechanism to sustain itself from other independent entity, you know. So it means itself, the maintaining itself is actually a goal. So making the boundary and making the individual as a independent entity is actually related to a goal or normativity. And same things, like when you define normativity, you need to define individuality first. So this is just an example the manual actually pointed. Like if you see the agent as, okay, the person like cycling with a bike, if you define a goal as exercising, you know, the agent is just a human itself. The bike is just a tool. But if you think the commuting the work as a whole goal, the bike itself is not a environment. It's actually part of the system. It's an agent. So the defining goal actually determine what the individuality is. So it's actually these, especially all these kind of formulation, individuality and normativity is actually very close, similar concept. Okay. How much time I have? Like 8 minutes? 3 minutes? Okay, 3. Okay. So, yeah. I'm just going through, so I think I talked too much for the first part, so I'll just briefly talk about. So far, I just talk about the paper with manual. Like, we have so many different way to apply, different way to define agency mathematically. But these are like all as if stance we concluded. But we need a bit more, you know. We need to understand like what is a actual generative mechanism. Otherwise, we can only see the system as a kind of interpretation. Never understand the system as it is. System as a kind of generative power to define itself as an agent. So in the second part of my talk, I don't think I have a time to go through all of them, but yeah, we kind of put this idea, internal coarse graining and downward causation. So I just put just the diagram. So internal coarse graining and downward causation. Sometimes it's a very controversial because the actual strong downward causation actually never happen in a physical system to me. Here I just mean like a weak version, you know. It's just constraint. Like some macro variable can actually affect the micro variable as a, you know, not the, how to say, ontological way, but just a constraint the micro variable. And internal coarse graining is just information compression, but the internal means like a system inside itself do this compression. So I think these two concepts is very important, and it's kind of the new like glass to understand the actual, you know, mechanical cause of being agent. And I just put some example to explain this. Sorry, there's an example, and then I just conclude. So I think the one things I think this is the study by what's the name? The guy in Santa Fe. Fontana, Walter Fontana. It's a bit old paper, but he said he claimed that you know, molecular interaction system can be seen as an internal coarse graining. Means, so you know, the molecule has so many, you know, different parts, and then, you know, when they interact, some part is actually more important than the other part, and they actually define the like a, you know, interaction rule, not taking account of the all the, you know, detail, but ignore the lot of part. And still this kind of coarse grain model can explain the actual dynamics. And of course, this coarse graining is done by human scientists, but when you actually simulate it matching the actual dynamics very well, it means they actually define this rule based on what the system itself actually see the other things. You know, like if this coarse graining is done by the scientists, it might be, you know, deviating from the actual dynamics. But when you can actually see the system itself actually following this coarse grained version, maybe you can actually say this is internal or intrinsic coarse graining. And another thing is the downward correlation. For example, I think that people already talk about a lot of E. coli, but you know, like E. coli can actually use the temperature as a cue to predict the next oxygen level. And that's good, but also it's interesting evidence that they can actually decouple this association by putting the E. coli in a kind of inverted environment. So normally, the E. coli predict higher under the high temperature, they predict a lower oxygen. But if you put the E. coli in a opposite environment, the E. coli predict the other way around. So it means like the association is not just hardwired; it's actually like a kind of model learned from the environment. So again, like this is maybe still interpretation from observer, but this is kind of to me, the system actually doing some kind of downward causation by, they just only take the temperature as a macro variable and can actually affect the micro variable. So, so again, like this, the second part, I'm not saying this is a mathematical or formal definition of agency, but when we actually thinking about the defining agency, we need to go back to the biology because we at least know mechanism, how it works in an actual system. Okay, so taking this kind of point of view, I think I just put the last slide. Again, this is a bit provocative claim, but I just put a lot of different type of system from, I think the far left is more like a lot of people agree this is not the agent. And if you go to the right, it's more agentic. And we just define the agency using this internal constraining and downward causation. And also, I didn't explain very well, but the internal-external gap means like when you see the system mechanistically doing some kind of internal constraining and a downward causation, we as an observer can actually do the same, like modeling the system from the observer perspective. But my claim is this gap between the system intrinsic system dynamics and what we actually interpret is actually defined in agency. Means if this are converged, the internal external is converged. It's not actually very agentic. The actual human or biological system actually always diverge from what external interpreter try to model. So that's my final take. So Rolling Stone, of course, there's no internal constraining. There's just simple physical system. What governor? I don't know. I would say there's no macro variable created by internal system, but at least this arm controlled by the speed of the, I don't know why it's called, ball, is affecting the kind of speed of the, sorry, which way? Changing the kind of, the volume of the water. So there is some kind of control. So yeah, it's kind of just a simple feedback system, but I would say like there is a downward causation without constraining. Variational autoencoder is just, again, this may be not the internal constraining, but like variational encoder just compress the information from the data to the latent space. This is maybe internal constraint, but without any downward causation. Brightenberg's Beagle is just a simple device. There's no constraining or downward causation. Deep learning system, maybe LLM has both now. They are internally constrained their variable, and also maybe downward causal system downward way. But problem is, the system is trained as a mapping to it's aligned to the human. So there's always, maybe not anymore, but I don't know. Like LLM, maybe which is just a very good copy, good mimicry, because it's just converged to what human want. And only the maybe so for a biological system like a bacterium, human, would be the, this divergence of the gap between the interpreters or external observers model and internal mechanism of the system. Okay. That's my, a bit provocative claim, and you can, of course, object to it. It's just making like a framework like this. And so this is my summary slide, and my last take-home message, just this. So individuality is kind of, you cannot define as a kind of static boundary. It's always like a dynamically, adjusted by itself. But I think like nobody actually talking about internal-external gap, but as a part of definition of agency explicitly. And I don't know what we can actually say after this, but at least this framework can maybe explain like what is agency, what is individuality in not just a kind of biological chemical system, but beyond the kind of system AI or even like a social system, economical system. Okay, I will finish my talk here. Thank you very much.